So we'll approach this question by examining some of these values at some common values. So the first thing I'll do here is factor out a 2 in the numerator so I can see where it's 0 and what else is happening. So if I factor out a 2, that's that, and I can factor this quadratic. So that would become x minus, actually x plus 3 and x minus 1. So that 2 drops out. So now it's a little bit easier to see what this looks like. So I'm also going to examine what happens when x is 0. So this would be minus 3 over 2, 3 times minus 1. So that becomes half. So I know if I were to graph this, then that this point here is 0, comma half. So that immediately eliminates these two because half would fall in the range. So therefore it has to be between C and D. Now, this is the hard part between how do we distinguish between those two. So if we look at what happens to this function as x becomes really large, you can drop this term, and then again 4x would be really small compared to 2x squared. So it will become 1 over x, and it is positive if you're looking on the positive x-axis. So it's going to go to 0 as x becomes large, so something like that. But I also know that when x is equal to 3 over 2, so over here, 1.5, it's 0. So the function has to go something like that. It has to go through a maxima somewhere here because it's 0 here and then it's approaching 0. So it's going to be critical about finding that point here, that maxima. So we can examine it. So we know this point is 1.5 comma 0. We can plug in x equal to 2 to see what happens. So 2 minus 1.5, that's half. That's 5. 2 plus 3, and then 1, so that's 1/10. So let me list them here. When x is 1.5, the function is 0. When it's 2, it's 1/10. Let me try 3. So if you try 3, 3 minus 3 over 2, that's 1.5. 6 over 2, that becomes 4, 1/8. So that's 1/8. And then if I try 4, 4 minus 1.5, that's 2.5. 7 over 3. 4 plus 3, 7. Yeah, I just have to make sure. 2.5 divided by 3 divided by 7. I think I'm doing it right. It's 0.11. So you can see it's starting to decrease. That's 0.125. So the question is, where is the maxima? And I think the way I kind of looked at it is I can try these two values, 2.9 and 3.1, which are a little bit to the left and to the right of 3.1. And if you plug that in here and compute it, you will find that both of them are slightly less than 0.125, both of them. I don't know exactly what the values are, but they're slightly less if you plug it back in here, which means that 3 is the maxima. And that means this is the maximum value, and that kind of eliminates this answer choice has to be between minus infinity to 8. Now, I didn't comment on what else happens to the graph. So as you approach x equal to 1, this is your asymptote here, it's going to go to negative infinity. And that's where that negative infinity comes from. And on this side, as you go up, it's going to go positive infinity. And then again on this side, and these are kind of important properties you need to know about the asymptotes. Minus 3 would also be an asymptote. As you can see, it will approach 0. So here, it's going to go like that. And then we'll have this, and then it will go to negative. We'll be getting to 0, but going towards the negative. And that's why that's the answer. But the key part here was to kind of identify whether that's 1/8 or 1/4. So I'm not sure what they're trying to test here. Because it's, you can't really find the maxima here. I mean, you could try calculus. It's just way too much work. But that's not how these questions are designed. So this is kind of how I approached it. There are probably other ways to go about it too, but this seemed to make the most sense to me so far. So the answer is C.